think we've done a previous problem with this, but this is a twist on it. So this is still a class B, and our default subnet mask is still the same. So we need 1,000 subnets and 60 hosts. How do we get that? Two to the what gives us 1,000? It's actually going to give us 1,024.
To 12? No, wait.
2 to the 10th? 2 to the 10th gives me 1,024. That means I have 10 subnet bits on. And then 6 are going to be my host bits. 2 to the 6 minus 2 is what? 62. They're always going to give you a question that works out in that way. You're not going to have the perfect number of subnets and then something totally weird in the host, like they want 10,000 hosts or something. They won't do anything like that. So that gives me 1,024 subnets. And how many bits were borrowed? 10. Because we're borrowing from the host portion no matter where that starts. So in this case it started here. So that's 10. Which makes our custom subnet mask what? When you convert that to binary.
255, 192.
Yep. 255, 255, 255.192. Because this whole portion right here is full of ones. So it's just going to be 255 like anything else would be if it was full of ones. And then we have 128 plus 64 is 192. Okay, so. So in this case, if we were to subnet the correct way, which I don't have specific questions for this one or anything, but we're going to start with 165.100.0.0, and then we're going to increment in the 4th octet, because that's where the changeover happens. Now I got my problems a little backwards. My increment 64, because that's where that last one stops. So in the 0 portion of this, there's 4 addresses. Then you'll roll over to 1, there'll be 4 addresses. Roll over to 2, 4 addresses. We know there'll be 64 or 62 usable hosts in the subnet because 0.63 will be the broadcast, and there'll be 62 addresses in between. So then that makes sense. Okay, now we're back on track. We got this. Cameron, would you mind opening the door? It's crazy hot in here. What's my cider for this problem? 26. Easy enough, right? These are already on. These are on 26. Okay, now we're going to be given 148.75.0.0 /26. So we know where this is going from the previous one, just based on that information. They don't give us subnets, yeah.
Excuse me, what's that say?
Huh.
That's 148.75.
Uh-huh. 148.75.0.0.
Okay.
So in this case, they didn't tell us subnet or host requirements, but they gave us a CIDR. So we're supposed to work off the CIDR. Well, it's going to end up looking like the previous problem did because it's still a /26. They just phrased it in a different way. So we end up with this again. But let's see how everything else gets changed. What class of address is this? Still a B. Our subnet mask default is the same. Number of subnets?
It'd be 64.
Is still total 64, 62. Hosts? Wait a minute. No, number of subnets is 1,024. 64, 62. We still borrowed 10 bits, and our custom subnet mask is still the same. Which means that when we subnet it out, it will still be the same. They just gave us the information in a different way.
Those would be different IPs.
Huh?
It's gonna be different IPs, right?
It will be different IPs, because they started with a different address. But it's still got your 2 octets back here that you have room to work in. So all that checks out. Okay, now the next one is a little different, but I think it's problem 6. It's one that y'all have in your packet. Yes?
Yes.
So problem 6 says we need 126 subnets, 131,070 hosts, mercy, with an address of 118.0.0.0. First things first, what class is that?
Okay.
It's an A. Our default subnet mask for a class A.
It's a different phone.
255.0.0.0. That's it. Now, so why do we have 3 octets to work with?
Does it say
Hmm?
A? Does it say A?
Yes, because it's an A, and because of the default subnet mask. Everywhere you see a 0 in the default subnet mask for that class of address, that's what you have to work with. So when we start counting for subnet bits, we're going to start right here and go this way, right? Okay, so we need 126 subnets. 2 to the what gives me 126-ish. 7. 2 to the 7th gives me 128?
Yep.
All right. So my total number of subnets is 128. Where does that first one go?
For second octet.
The second octet in the first spot, right? Okay. 1, 2, 3, 4, 5, 6, 7. Everything else is 0. There's a bunch of them though, because we've got over 2 octets worth of zeros. But that's okay. How many zeros do I have? 17. 8 here, 8 here, 1 here. So 2 to the 17th is what?
131,072.
What a coincidence. 131,072. Usable, we subtract that 2, 131,070. Isn't it funny how that worked? How many bits were borrowed?
7.
7. What is my custom subnet mask?
255, 254.
255.254.0.0. How did I get that? This is a 0, this very last octet that represents 1 in binary. So this equals 254. Any questions about that? That one's fairly straightforward, right? Especially if you can do the formulas. Why would you ever need 126 subnets with that many hosts on each one? I don't know. I didn't make the problem. But it is an option, right? Any questions on that one? That's a class A. Big scary class A. Y'all did it and you weren't even thinking about it, right? Because if you know how you got there on everything else. If we were going to actually subnet this, which octet would we start in?
Second.
The second. Why?
To the class and subnet line.
Because of right here, right? This is where the changeover happened. And when you think about it, if you're trying to get that many hosts, you're going to need a bunch of octets because you can only get 256 out of one of them. So you're going to need multiple, as you know, exponentially it increases. You're going to need multiple. All right. Problem 11 in your packet I gave you, 250 subnets. Network address 101-0-0-0, excuse me, dots. That's a class A because the first octet's less than 126, 7, 8, somewhere in there. Kind of depends on which book you're reading. Which makes my default subnet mask that same old 255.0.0.0. Okay, I need 250 subnets. How am I going to do that?
2 to the 8.
2 to the 8th. Very good. 2 to the 8th gives me 256, right? 256 total subnets. I need to write down 8 ones. I'm going to start in the second octet. Right? I'm going to start right here. 1, 2, 3, 4, 5, 6, 7, 8. Well, that's interesting. That's the whole octet. And that's all I need. So that means all these are going to be zeros. Bits borrowed? 8. What about hosts?
65,136.
2 to the what?
16.
2 to the 16th. Which is 65,536
530.
total. And if you subtract 2, you get 534. What's my custom subnet mask?
255.255.
255.255.0.0. So, they took a class A address and they subnetted it to look like a B. That's okay. That's fine. When you get to CSENT and stuff like that, you'll see that a lot of times there's subnets within subnets. So you might make a lot of small subnets and then you'll subnet within each one. We will not do that in this class, but that is a thing. So this is okay. Having an A that's subnetted down to a B, that's fine. Any questions about how we got those numbers?
For, like, where it says usable host, don't you take 2 off for each? Don't you
No,
take
2
for
off
each
in general.
subnet?
2 off in, well, I mean, when you actually do it, you'll have the 2 off for each subnet,
Okay.
but. Okay. Okay, number 4. 750 subnets. Network address of 190.35.0.0. What class is that? That's a B. Which means its default subnet mask is 255.255.0.0. How many octets do I have to work with? 2. The last 2. Very good. I need 750 subnets. It doesn't matter how many hosts. 2 to the what's going to give me that?
2 to the 9. No, wait.
With 10?
2 to the 10th. It's going to give me way more, actually. But 2 to the 9th would give me
Sorry, 512.
512. There you go. So total subnets is going to give me 1,024 because I'm going to borrow 10 bits. 2 to the 10th is 1,024. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 zeros at the end. 2 to the 6th is what?
64.
64. Which means 62 are usable. What's my custom subnet mask?
255.255.255.192.
There you go. So this is a B subnetted down to a C. Any questions about how we got those numbers? Okay, so now we actually need to subnet. Which octet are we going to change? If I get this one right this time.
Third octet? I
No.
don't know.
I'm on, wherever this 1 then 0 switchover happens. So in this case, I'm going to change in the 4th. Okay, which means this number is going to change first. What's my increment value?
64.
64. So in the last octet, I'm going to increment by 64. Okay. Starting here, I'm incrementing by 64, 64, 128, 192. If you add 64 to 192, you get more than 255, so we have to roll over. Okay? So, 1.64, we just start to repeat. Okay? So you see a pattern emerging here, I'm sure. So it's the same thing over and over and over. So if you do this 4 times for every subnet, then you get your total number of hosts. Your total number of subnets, I should say. Okay, first question, what's the 15th subnet range? Which one is the 15th one?
1.3, 19.25. Is that 20.3?
3.125?
Yeah.
3.128.
Right about that.
Yes, that's the 15th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the 15th subnet, okay? So if I want to find the range, what is the broadcast of that? 3.191. 3.191 is the address that comes before 3.192, right? Just like we did before. So my whole range is 190.35.3.128 to 190.35.3.191. What is the 13th subnet number?
.190.35.3.0.
There you go. 190.35.3.0. If this is the 15th, that's the 14th, that's the 13th. That's the subnet number, okay? Broadcast for the 10th.
190.35.2.127.
13th, 12th, 11th, 10th. To find the broadcast, we want one less than that. So it'll be 2.127. So your whole address is 190.35.2.127. I do want to point out, you asked a really good question earlier, and I don't think I really addressed it. Regarding this relationship, subnets and hosts. For this first one, your range is from 1 to 62, right? I should say 0.1 to 0.62. You have 62 usable hosts on each of those subnets. Is a better way to phrase that. Not in total, but on each of those 1,024 subnets. Here's one of them, you have 62 usable addresses. Just to point that out. The assignable addresses for the 6th subnet.
So 190.35.1.65 for 127. Or actually 126.
There you go. That's it. 190.35.1.65 to 190.35.1.126. Questions on that? Number 5. 6 hosts. We're gonna see kind of how bizarre this can get at this point. An address is 126.0.0.0. What's the class? It's an A. Which means our default subnet mask is 255.0.0.0. Now notice this time it did not specify subnets. It specified hosts. So I need to use my host formula, right? Subnets don't matter, we're just worried about hosts. So 2 to the what minus 2 gives me 6. 3. 1, 2, 3. 8 hosts, 6 usable. Heavens above, how many bits does that mean I have to borrow? What was that? 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And these 8 as well, right? $14, $15, $16, $17, $18, $19, $20, $21. Ugh. So I can use these last 3 octets. They're asking me about hosts. Hosts go right to left. So I got my 6 usable hosts here and a crap ton of subnets, right? Because they're the ones. So there's a lot of them, okay? So I borrowed 21 bits to get here. How many subnets does that give me?
2,097,152.
There you go. 2,097,152 subnets. That sounds ridiculous. If I was a person that you was an ISP or did some sort of domain hosting or something, I might need a whole bunch of subnets, separate subnets with little bitty blocks of addresses in it. What does that make my custom subnet mask? I know the 255.
255, got 255, got 248.
Yep. 255, 255, 255, 248. Mercy. So that's a class A subnetted down to a C. Ooh. My first address, I always start with the 0 network, 126.0.0.0. Which octet changes?
4.
The 4th. Where the 1s and 0s switched over. That one changes first, and what is my increment value? You know it's going to be small, right?
8.
8. Hence all the subnets, right? Because the increment is really small, which is going to make it .8, .16, .24, 32, 40, 48, 56, 64, 72, Rosie?
Yes.
So 72, 80, 88, 96, 104. How many are we up to? 1, 2, 3, 4, 5. Okay, we're good for purposes of this problem, but we're not even halfway through the zeros. We haven't even turned over to here yet and look at all the increments we have. That's how we get 2 million plus subnets. Same rules apply. What's the range of the second subnet? Corey?
I can't see it.
Oh, come on, you can't see this teeny tiny writing with green marker?
Actually, I do need glasses.
Oh, you do?
No, seriously.
Dot, dot 8. That's a dot 16.
Oh, so it's only vision hand in hand.
It's gonna be a dot 8 to what?
16.
0.15.
Ah. Well, not 0.1,
I said 0.15.
0, 0, 15. Oh, you said 0.15. And I totally thought you meant something else. But that is also what 15 means, so you're good. So from 0 to 15, that's the range of the second subnet. What's the number of the fifth subnet? Eduardo, what do you think?
Point 30, wait, 0.39? Is that a 4?
It's a 2. God, I didn't know my writing was this bad, y'all. That or your eyes are all terrible, but I'm gonna think it's probably my writing. But yes, it's that one. That's the fifth subnet. So what's the whole address?
0.39? I mean, 39?
It's 32. But the whole thing, like this is.
Oh, 126.0,
Okay?
30, 33?
32. We're looking for the subnet number, so we're right here.
Oh,
And y'all be careful, it's dot whatever. Get in the habit of saying 126.0.0.32. So just be sure to pay attention to that. That's our fifth subnet. That makes this my seventh subnet. And I want the broadcast address of the seventh subnet, and what would that be?
Dot 55.
Yep. 126.0.0.55. The 10th assignable 7, 8, 9, 10. What are the assignable addresses, the full assignable addresses of the 10th subnet?
126.0.0.73
Mm-hmm.
to 126.0.0.79
No.
or 78.
78, there you go. Very good. This is why we went over default subnet masks, right? So that we know where we're supposed to start. And then we've got to pay attention to where do the ones and zeros change over, because that's the octet we actually start incrementing in. All right. Problem 6. Looks tame in comparison. Bless you. Ten little subnets. 192.70.10.0. what class? C. Default subnet mask of a class C. 255.255.255.0. In this instance, what octet is going to change?
4.
The fourth. It's the only one available. We cheated. Now we know that, right? When we look at everything on a grand scale, it kind of starts to come together. I need 10 subnets. How many bits need to be turned on to give me 10 subnets?
4.
4 little bits gives me 16 subnets. 2 to the 4th is 16. 1, 2, 3, 4. 1, 2, 3, 4. 16 hosts, 14 usable. Custom subnet mask, 255, 255.255, what?
240.
240. Now we come back around full circle to the way we're used to it being in Class C. In the same way, we use the fourth octet because that's where the ones and the zeros switch over. Okay? We always start with 0. 192.70.10.0. My increment value is 16. Rosie, help me out.
96.
96. 96 and 16.
112,
112.
128,
128.
144,
144.
160,
160. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're far enough. You're so good at that, Rosie. Thank you. 312.
We need 12.
Huh?
We need 12 subnets.
Oh, dang, we do. 176 and
192.
192. There we go. You're right, you're right. What's the addresses in the 9th range? That's the 9th one.
At 128.
Mm-hmm.
We have a 192.70.10. 128 to.
To what?
42. 44.
Mm-mm.
43?
43. 192.70.10.128 to 192.70.10.143. So it asks for the whole range, not the assignable range. It wants beginning to end. And what's our 4th subnet number?
48.
48. 192.70.10.48. Right there. What's the broadcast of the 12th?
The 207.
No,
191.
191. There's the 12th. Starts at 176, one less than that. Right there, 191. 192.70.10.191. The 10th assignable range.
145 to 158.
Very good. 145 to 158. Because one less, be 159. So 192.70.10.145 to 192.70.10.158.